what confuses a lot of students is we're looking at a model that has two halves to it.
Okay.
The complete thing would be having all of this covered, but they've sliced away the parietal layer of the Bowman's capsule is here. That's the outer part, made of these flat cells. These brown cells, though, are the visceral layer. They form the visceral layer of the Bowman's capsule. And the cells themselves are called podocytes. And they're the weirdest cells in your body because they have these vine-like feet that grow around the capillaries this way. And you'll notice these little slits, those are called filtration slits. And when the blood comes into the capillaries, it oozes out through these slits into the capsular space, and that's the filtration process. And that control, what this filtration setup, the membranes and the filtration slits do is they control the size of what's filtered. Anything small enough is going to filter through there, and that includes water, sugar, amino acids, vitamins, electrolytes.
So this
all of that goes into here.
Is this?
Mm-hmm.
Yeah?
These are these right here.
So then what's the brown?
Yeah,
And
so
the
what-
brown would be, I suppose, the podocytes is what they're trying to show there. These would cover the entire thing if it were in, you know,
Okay, one whole thing.
over here they've been stripped away so you can see the capillaries. If you look very closely at those capillaries, you'll see they have holes in them. Not really, but they're little dimples are supposed to be holes.
This
They're
is,
fenestrated
I can see
capillaries.
it from now. This is a covering over these, so
Right.
these are under here.
These are there.
Oh, so it all should be
I
brown.
cannot-
This
It
is
all
over
should be
this.
brown,
It should
yeah.
all be
This
red.
is over that.
Parietal layer,
Look at
visceral
that.
layer, visceral layer made of podocytes. You see the silver little ovals? Those are the nuclei of the podocytes. But all the podocytes
is
together make
inner.
up the visceral layer of the Bowman's
And
capsule.
that's why when you said
The
visceral,
inner
I'm like,
lining.
how does that work?
The
Because
inner
they're
lining.
little. But now I see it's covering.
This is a visceral layer.
Yeah, the
Right.
brown is covering the red.
Yeah, the brown should be covering it all.
This is-
Yeah, the brown should be on
Now
top.
I see because then you're like, she's.
And this is
Check
what-
your textbook
Yeah.
and PowerPoint. The PowerPoint, I think,
brown should be
I believe it's the same
Yeah,
picture in your
they just
textbook.
took it away so
Okay.
you could see.
They got a much sharper, clearer picture and analysis of these podocytes, how they
Got
look
it,
and
okay.
everything.
And then these are
But it's
the
really cool
capillaries.
anatomy, and it's really neat.
Okay,
This is
okay.
the afferent arteriole where the blood comes in.
Afferent.
This is the efferent where it goes out. And why is the efferent splitting? Because it's going to divide and form paratubular capillaries. All these paratubular caps here.
Where's
Uh,
that
here,
And these are paratubular caps. To see this efferent one coming out?
and these are the two
Yeah,
splits right
it starts
here.
to form this capillary. That's why this is split like that, like a
And
forked
this one
tongue.
is which, where?
Afferent. That would be
Can you
this
see
one
the-
here,
Okay.
coming in.
And then this would be this one?
This comes right off of the cortical radiate artery.
Oh, here, this is this, and this is all
Right.
of these.
Say that
Okay,
again, say that
makes
again,
sense.
say that again. This is what now? This?
Yeah, see
Afferent.
how that one goes right
Yeah,
from
it's
the main
this
straight
one
in?
and also this one. They're the same
Right, how-
thing.
the one that goes
And
straight
over
to
here
the
it would be
vein.
these, my big fat finger, you can't see what I'm pointing
But
at.
then you can see how this
Now
one
I don't
goes
know
out,
what I
did with
splits
my
that way,
pen.
and splits
Here, I have
this
one
way,
right
and
there.
goes out.
These are these,
Yeah.
these,
Okay.
and this, all the same, afferent arteriole.
Afferent, they're
Afferent.
going in, okay.
Going
and then
at
this-
or toward.
At, and then efferent.
And exiting would be the
Exiting.
efferent,
E,
which would
and
be
exit.
this one, going to nowhere.
Okay, and then
Going to nowhere.
this one.
This one right here, which is
Going
kind of
to-
strange looking, but this is a little easier to see here. This is an efferent
That
one.
one.
Here, see.
Going out to the
To form the
capillary beds.
paratubular caps, capillaries. You'll see why we have paratubular capillaries, because they are all around the tubes, and they have to be there to take back water and other, and nutrients and all that from the filtrate. And also
Okay.
add some waste to the filtrate too.
So what is this?
Bye.
This is.
Proximal convoluted tubule. That would be this right here.
Oh,
that's
right,
hard to
and
tell
is
on this
the,
model, but-
distal.
Uh-huh. The distal on this one would be, let's see now, this right here. This is the distal tubule there.
Where does it come out of it, though?
So mixed up there. There's the proximal. This is distal here. See? I don't use this for that because you can hardly tell, but I can tell by just following it that this is going to be your distal
So proximal.
tubule. Proximal is this one right there.
Doesn't the proximal hook to the distal? Yeah.
No, they're separated by the Henley's loop. The
Okay,
Henley's
so
loop
it
is
goes to
between
the
the
loop.
proximal and the distal tubule, is the Henley's loop.
But
So-
it's still the same loop,
Yeah,
yes?
but it's so hard to tell here. Let's see if this one's any better right here. This is the proximal tubule. Here it comes down. God, it's hard to tell, but this looks like descending limb. Yeah, I can tell this is descending because the thick segment's much greater on the ascending.
Ascending, okay.
This
And
is
that's
ascending.
Uh-huh,
Comes up to the distal tubule,
uh-huh.
and this
And then it
goes
goes
into
down to the-
into the collecting duct. But they don't even bother, Professor Laborda, when he had this label, he didn't bother using these. We'd rather use these for those tubules.
Just because they're easier to
They're easier to see.
Yeah, yeah.
But you can definitely
just
tell
so-
the glomerulus and the Bowman's capsule and all the vessels here are
So-
quite distinct.
Can you say
Now, other vessels I wanted to bring, pardon?
which one is ascending, which one's descending again of these?
Well, if you follow the proximal tubule, it's
Mm-hmm.
a lighter green one here.
Okay.
This is the descending limb.
Descending, all right. 'Cause
Then it
it
loops
starts
up
from
and
here,
comes
goes
to
down.
the ascending limb here, and you can tell it's dark green and it goes to the
I see.
distal convoluted tubule.
Okay.
Then it connects to the collecting duct and goes to papillary duct and out. Now, there's one system of blood vessels that I forgot to mention to the other folks, and that's this. But you'll see it labeled vasa recta here. These are the blood vessels that loop, along with Henley's loops, go down into the medulla, the pyramid, and back up again. And it's a technical thing. It really is hard to understand how it works, but if you read in the book about it, and also look at some of the videos